Welcome to the final presentation from Team Identification International. We have been collaborating and working with the company Voestalpine Aerospace, which produces forged parts for the aviation industry. Now, when the parts produced are as critical as weight-bearing landing gear components, there is no room for errors. It is therefore no surprise that there are very strict regulations on the processes and parts tracking, even down to every single produced part with a unique identifier. With these requirements in mind, and also the need for using new technology to compete with future markets, we have come up with two solutions to streamline the process. Now, to put our two solutions into context, let's have a look at this simplified map of the processes we are dealing with. First, the parts are sorted by their serial number before being inserted into a giant furnace. After being heated in the furnace, they are inserted into a screw press, and in the screw press, they are forged and the serial number is lost. Both these steps of sorting and restamping are done completely manually, and that's where our two solutions come into play. Now let's have a look at our two solutions. On the left-hand side, you can see the parts tracking, which is assisted by a computer vision. This helps by sorting the parts before entering the furnace. On the right-hand side, you can see the digital hammer, which remakes the stamping after the forging has been done. Like previously mentioned, both these steps were done manually, but the automation is not only the added benefit, but also the creation of digital tracking history of the parts. Now, let's have a look at our solutions in more detail.
Now, how does our optical character recognition system work? Instead of the worker sorting parts manually before they enter the furnace, now a camera takes pictures of them, sends them wirelessly to a remote server where they can be processed, the serial number is extracted, and the timestamp is added to the database for quality control. How does our system achieve this? Well, we have industrial-grade cameras which take RGB images as an input, then they are turned into grayscale. With a Python code, the edges are extracted and are then fed into a Tesseract algorithm which recognizes the serial numbers and adds them to the database along with a timestamp. Now, one of the problems is that the metal surface is very noisy, so this algorithm can be drastically improved if in the future a neural network is used which is trained specifically to extract numbers from the metal surface. The digital hammer is our second solution, and it was recognized as the most promising way of both improving the worker's job and increasing digitalization. It removes the need for the worker to manually stamp the part and also hit the part with his own force by using a pneumatic single-shot air gun. On it, an automatic indexing head is mounted, which both changes and stamps the number. The whole device is controlled by the electronics module, which also communicates with the database to add the points to the system. Now, this device reduces the chance of error, saves time, and most importantly, the worker doesn't need to apply any force anymore. To show the plausibility of our device, we performed testing at first at the iim Institute at our university. We tested with small parts and had very positive results. Following this success, we had the chance to test our product also at the production facility of Voestalpine in Kapfenberg, where the workers got the chance to stamp with the device themselves. They were impressed by the simplicity and ease of use and expressed the desire to integrate the digital hammer in their future workflow. We also learned a great deal during the trials, including most importantly that we will probably need a larger device in future to mark deeper in the metal so that the marking is not lost during the next production steps. Also, an aiming aid, such as a laser, would be very beneficial for workers to help them hit the exact spot every time, as would be some heat shielding to guard them from the radiation of parts exceeding 900 degrees Celsius. It is the integration of all of these components, such as the index head, the display, and the actuator, that will complete our product and realize the digital hammer's full potential. All of these parts exist separately, so it is just a matter of implementing them together to finish our product. Voestalpine have already shown interest to pursue this in their own research and development facility. We are Team Identification International. Thank you very much.